right, lesson 4.2, task 3, we are adding and subtracting polynomials. All right, to add two polynomials, add the like terms of the two polynomials. When working with polynomials in one variable, like terms are monomials that have the same variable and exponent. Two methods for adding are shown. All right, method 1 is vertically. All right, so they put each polynomial in standard form. You can see they've rewritten this as cubed, squared, linear, and constant term. And they did the same thing for the second one. So cubed, squared, linear and constant term. That way, all you have to do is add the coefficients vertically. So 2 minus 1 is 1x cubed. The variable and exponent do not change. Here we've got 3 plus 6, so 9x squared. Negative 7 minus 8 is negative 15x, and negative 9 plus 12 is 3. So the vertical method, you just put the polynomials in standard form and then add like terms going down or vertically. All right, so it says first polynomial in standard form, second polynomial in standard form, add terms vertically by adding coefficients, then simplify. All right, method 2, horizontally. All right, horizontally, they're going to regroup using commutative and associative properties. So they're going to regroup and put like terms together. Then they're going to use distributive property to factor out the variable with the exponent, and then do the same thing as above. So 2 minus 1 is 1x cubed, 3 plus 6 is 9x squared, negative 7 minus 8 is negative 15, and negative 9 plus 12 is 3. So the last thing they do is put it in standard form. Okay, so those are two methods that you can use. All right, it says describe how the methods are similar and how they are different. Select all true statements. The horizontal method puts the polynomials in standard form last. Well, that is true because it did use commutative and associative, distributive property, but the last thing they did was put it in standard form. The horizontal method gives a different answer than the vertical method. That's not true because if you look up here, you can see that these have the exact same answer. So that one is not true. And then it says the vertical method puts the polynomial in standard form first. Well, that's one of the first things. Put it in standard form first so that you are combining like terms and it's already in standard form. So that one is true. And then it says both methods put it in standard form first. Well, that's not true because we've seen that this one did it last. Horizontal method did it last, not first. And both methods involve adding the coefficients of like terms. Well, that is true. It didn't matter if it was vertically or horizontally. You can see that they did add the coefficients of those. So that one is also true. So there are 3 correct answers for that one. And it says, which method do you prefer? I don't really prefer either method. I think the first method vertically makes it nice and neat and easy to do, but it's just as quick to locate the like terms horizontally as well. So you can decide which method you like. Both of them will result in the same answer as long as you do it correctly. All right, we're going to move on to task 4. All right, so now it's subtracting polynomials. So task 4, to subtract a polynomial. To subtract two polynomials, add the opposite of the subtracted polynomial. Two methods for subtracting are shown. Method 1 is vertically again. So you can see they took the first polynomial and again they put it in standard form. This time they took the second one first. All right, it says two methods for subtracting this from this. So that's why they put this one first. We're subtracting from this. So this 8y cubed minus 3y squared plus 5 goes on top. And you can see they put a 0y as a placeholder because you don't want to combine the 5 with the y. So if it's missing a term, this one was missing the linear term, just add 0 as a placeholder. And we'll do that a little bit later when we're dividing polynomials as well. So this is good practice. Then again, you're going to put the second one in standard form as well. And you can see this is minus 2y cubed, and they've got plus. So it was going to be subtract the opposite, which two negatives make that a positive. Okay, and then the negative 12. So because they're adding the second one, they've already changed all the signs here. So that's a good way to look at subtracting polynomials. It's probably the easiest way that you don't lose the sign. Go ahead and change the signs in the beginning so you can just add. So we've got 8 plus 2 is 10. Negative 3 minus 12 is negative 15. 0 and 9 is 9. And 5 minus 6 is negative 1. All right, down here, they distribute the negative first, which is the same as what they did up here, sort of. It's just they didn't show it in this step. So negative times negative is positive 2y cubed. That's where that came from. Negative 12y squared plus 9y. And negative times positive 6 is negative 6. So now they're adding just like we did in the last example. So they factor out the y cubed, or they use the distributive property to rewrite that. And then the last thing they do is put it in standard form, which means it goes from its highest exponent to its lowest. All right, describe how the methods are similar and how they are different. Select all statements that are true. Neither methods group like terms. Well, that's not true. They both kind of group like terms so that they can add like terms to put it in standard form. Both methods subtract by adding the opposite. Okay, we did see that's true. The vertical method puts the polynomial in standard form last. Nope, that's not true. The vertical method put it in standard form first, so that one's not true. The horizontal method adds like terms by identifying terms with the same exponent. That is true. Both methods give you a different solution. You can look back again. They get the same solution, so that's the only two answers. All right, that's it for task 4. We're going to move on to task 5. Task 5, model using polynomial addition or subtraction. A fitness supply company manufactures stretching rollers. The function O of x and R of x give the number of online sales and retail sales in thousands during the X month after being placed on the market, respectively. Estimate the total number of sales during the 4th month. The function T of x equals O of x and plus R of x. You can see O of x and R of x are original two functions. So when you add those together, they're going to call it a new function called T of x. And the function T of x models the total number of sales. So O plus R, they come down through here, and it looks like they're using the horizontal method. So what they do is rearrange, group the like terms, and then they use distributive property to factor out the variables. And then the last thing they do is put it in standard form. So question 1 says, how can you describe which pair of terms to add in the second step in this equation? All right, so how do you figure out which ones to add together? The ones that have like variables or like terms. So add all like terms, add them all together, look at the sign in front of the term, look at the coefficient. So you're going to add the like terms, which means they have the same variable with exponent. Which property allows you to write the sum in a way? So this property here, that's the distributive property. I can't talk. Yes, so the property used to write the sum of products as the product of two sums is the distributive property. And then it says you can substitute 4 for X to find the total number of sales during the 4th month. So if you remember in the very beginning, it said estimate the total number of sales during the 4th month. So all you have to do is substitute 4 for X, and that gives you about 332. So it said in thousands at the top, so that would be 332,000 stretching rollers were sold online in retail sales during the 4th month. All right, that's all for task 5. If you have any questions, let me know. All right, task 6, this is the final task. So model using polynomial addition or subtraction. According to data from 2010 to 2018, the monthly value of U.S. exports can be modeled by the function e of x, where x is the number of months since the beginning of 2010, and e of x is the value of exports in millions of dollars. Similarly, the monthly value of U.S. imports can be modeled by the function I of x. Estimate how much more the value of imports was in January of 2014 than the value of exports. All right, so the first thing we have to do is find the difference of imports and exports. So it says the function d of x equals your imports minus your exports, models the difference of imports and exports. Subtract the polynomial function that model imports and exports. So the models given here or above, so they've taken those and they've added the opposite or subtracted these. And it says, why is the difference written as addition instead of subtraction? So just like in the last example, it's like you kind of distribute that negative to the second polynomial so you can add those terms together. And that way you don't lose a negative as you go across. It's better to distribute it to each term first, and that way you don't have to remember to go across with the negative at the end. So the polynomial for exports is subtracted by adding its opposite. How do the coefficients in the difference relate to the coefficients in the polynomial functions? The coefficient of each term in the difference is the difference of the coefficients of like terms of the polynomials being subtracted. All right, now it says substitute 48 months for x to find how much greater the value of imports were in January of 2014. All right, so in the very beginning it said that estimate how much the value of imports is in January 14. But if you go up here, it says the data goes from 2010 to 2018. So X is the number of months since the beginning of 2010 in millions of dollars. So since this is from the beginning of 2010 to get to January of 2014, that's 4 years. So 4 times 12 months is 48 months. So that's where the 48 comes from. So substitute 48 for X to find how much greater the value of imports were in January of 2014. So this is the difference. This was our new function after we subtracted imports from exports. And then we're going to substitute 48 in for X. And it gives us 42,000. But remember above it said in millions. So then that converts to the value of imports was about 42 billion more than exports, which is probably not good. Like our imports and exports should be about equal. This shows that we are importing way more stuff than we're exporting, if this data is correct. But that is task 6. If you have any questions, please let me know.